Hi, in this video we're going to be talking about a special quadrilateral, the parallelogram. Parallelograms are unique in that they have two sets of parallel sides. They kind of look like a rectangle that got squashed a little bit, but it does have two sets of parallel sides. That's where it kind of gets its name because it's got all of those parallels in it. So if we wanted to like draw some of these, the idea of parallel means same slope. If I wanted to make a parallelogram, JOKI, so it'd be JOKI should be somewhere down here. I want to make sure that JI has the same slope as OK. So from O to K, I go up 1 over 1, 2, 3, 4, 5. So to I should go up 1 over 1, 2, 3, 4, 5. Then I should see a good slope that matches from JO. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So this would be the location of I making a parallelogram right here. If I wanted some point n so that JNOK is a parallelogram, maybe I want to have n out here, so I can go JNOK. So I want to make sure that the slope from O to K, again, that's up 1 over 1, 2, 3, 4, 5, is going to be the same for this n that's over here. So I go down 1 over 1, 2, 3, 4, 5. So that this slope, up 1, 1, 2, 3, 4, 5, matches this slope over here, up 1 over 1, 2, 3, 4, 5. And that matches from J to K. So this is up 5 over 1, 2, 3, 4. And then this is also up 5 over 1, 2, 3, 4. So we kind of end up with this other parallelogram. That looks like that. And this is the last one. This one I'm probably not going to draw because it's just going to make a big mess. But we want JO, probably we'll put G up here so it could get out of the mess a little bit. So if G's up here, we want to make sure that the slope from O to J should be the same as the slope from K to G. So this is back 1, up 1, 2, 3, 4. So back 1, up 1, 2, 3, 4. So G would be up there. I'm not going to draw it, but you kind of want to imagine a parallelogram right there. Parallelograms have this cool property. A quadrilateral is a parallelogram if and only if the opposite angles are congruent. Note this if and only if. That's one of those biconditionals. And what's cool about those biconditionals is if we get a parallelogram like this, then this is true. And if we find this, then this has got to be true. If we just see this, then we got to know, hey, these sides have got to be parallel. So in this one, the diagram's kind of bad here, but these are little kind of like parallel ticks. They're not congruent ticks. So this is a parallelogram. So we got to know that, hey, this side and this side have to be congruent. So we know that the measure of angle 1 is congruent to the measure of angle 3. Great. But we also know that about these two, that this big angle here is congruent to that big angle here. In fact, actually, there's these like kind of triple marks up here and the triple marks over there because these two, this angle right here and this angle right here, these are alternate interior angles. 4 and that 27 degrees are alternate interior angles, which are congruent. So we know from that the measure of angle 4 has got to equal 27 degrees. We get the same thing with this 52 and the 2. They're using this side and this side to make alternate interior angles again. So we know that 2 and 52 are also alternate interior angles. So the measure of angle 2 has got to be 52 degrees. Okay, based on that, so I put in the two measures that I just got. Hey, look, this is a big old triangle. And I know that these two have got to be the same. So once I find one of them, I really have found both. I'm going to do 3, because why not? I know inside of this big triangle here, there's 180 degrees. So that 180 degrees should equal the measure of angle 3 plus 52 degrees plus 27 degrees. So that's going to give me the measure of angle 3. And I get 101 when I subtract these two from that 180. So 101 degrees is the measure of angle 3. And if I bring this back up to here, that tells me the measure of angle 1 has also got to be 101 degrees. And that's done. All right, we're going to do a couple proofs just to kind of remind ourselves of some of that stuff. We've got Rust and this guy are parallelograms, so we know that these lines have all got to be parallel. So these two are parallel, these two are parallel. And we know that these lines are all parallel, 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 parallel. Okay, we want to show that this angle and that angle are congruent. So we've got the vertical angles UST and ZSW. So UST is the angle right here, and ZSW is the angle right there. Great, those two are congruent. They're vertical angles. R is going to be congruent to UST. Is our next statement that we've got. Angle R is that one thing that we're looking for down here. And so we can say that these two angles are congruent using the theorem that we just talked about, the quadrilateral opposite angles theorem. As a note for you, just so that you can reference it, it's 4-7, but you never need to really remember that. Okay, we can also say UST is congruent to ZSW by the vertical angles theorem. That is an old one that said vertical angles have to be congruent. ZSW and V, so ZSW and V up top here also are congruent, and that's this same thing. That's that quadrilateral opposite angles theorem. 4-7 again. Oh, wait. So if this is congruent to this, and this is congruent to that, and that is congruent to that, oh, wait. Then by a chain of congruencies, we can say R and V are congruent. And when we're using that big chain of stuff, that is the transitive property. And we're done. Great. Let's do one more. So we're given that these two angles are congruent and these two angles are congruent. We're going to prove that that has to be a parallelogram. So this is half of that quadrilateral opposite angles theorem. We're going to show where that comes from. So we are given that these two angles are congruent and these two angles are congruent. We're going to say that the measure of angle J is going to be X, just so that we have a value for that. And the measure of angle M is going to be Y. Since they're congruent, we can say that the other two have to equal X and Y. So we can say this is X and then this one is Y. And we're just doing that just because it's going to make it easier to do what we're going to do here. The sum of the measures of the quadrilateral equals 360. And we're doing this of 2 times X times Y. That's just like a little bit of simplification. We got to equal 360 using the angle sum theorem. That's the one where it's n minus 2 times 180. If we do n minus 2 times 180, then 4 minus 2 is 2 times 180 is 360. So we've got this. We made it that. And then what we did is we got rid of this 2 and we divided that 360 by 8. So that is the division property of equality. Okay, so J and M are supplementary and K and L are supplementary because if we take X and Y and add them together, we get 180. X and Y, we get 180. Using the definition of, well, that's what supplementary means. So JK and ML, JK and ML have to be parallel, and JM and KL have to be parallel because these two angles are same side interior angles. The converse of same side interior angles. Gives the idea that these have to be parallel and these have to be parallel. Whoop. So if those sides are parallel, hey, guess what? By the definition of a parallelogram, it's a parallelogram. All done. One final property of parallelograms we're going to look at in this video is the idea that diagonals are bisecting each other. These two are congruent and these two are congruent. This is also a biconditional. So if we've got a parallelogram, so whoop, then we know this is true. And if we see this, then we know we've got a parallelogram. So if we want this shape down here to be a parallelogram, that means these two have to be equal, as well as these other two have to be equal. So that means 12 has to equal our 2x, and that 3x minus 10 has to equal that y plus 2. So this is just kind of a little system of equations that we got to solve. I'm going to start over here with this one because that's going to be a little bit easier. I'm going to divide both sides by 2. So we get 6 equals x. Okay, great. So now we know what x is. I can plug that into here. So I've got 6, 3 times minus 10 equals y plus 2. So a little bit of solving and I'll figure out what y is. 3 times 6 is 18 minus 10 equals y plus 2. 18 minus 10 is 8. Subtract a 2 from both sides. 6 equals y. So boom, we got two nice little easy values by just setting up those two little equations and plugging what I got into one into the other one. That is it for this idea of parallelograms. Now, I hope this initial example didn't throw you off. The major thing I want you to be thinking about with parallelograms from this video is if you got a parallelogram, you know the opposite angles are congruent. And if you got opposite angles are congruent, you've got a parallelogram, as well as if your diagonals are bisecting each other, that's a parallelogram. And if you've got a parallelogram, the diagonals bisect each other. Thanks for watching. Bye-bye.